Hi, I'm Sean McCauley, and this is my answer to question number 4. So, lipolysis is the breakdown of triglycerides, and triglycerides are stored in the adipose tissue. It's driven by low blood sugar, and there's 5 steps to lipolysis. They're mobilize, transport, which is also known as cellular uptake, um, activation, there's translocation, and then there's oxidation. Um, it's triggered by a few hormones, specifically epinephrine, norepinephrine, testosterone, and cortisol, all of which are induced by exercise when we start exercising. And the first goal of the first step, mobilization, is to break apart the three fatty acids from the glycerides, um, and send the fatty acids into the bloodstream. Now, fatty acids can't travel through the bloodstream on their own, which is where albumin comes into play, and that's the second step. And so in this step, albumin transports the fatty acids, the free fatty acids, through the bloodstream. And then where sarcolemma, sarcolemma fatty acid binding protein, attaches to the free fatty acids, taking it from the bloodstream and moving it into the skeletal muscles, which is that third step. And then, or that's and they that's the yeah. During the activation phase, the free fatty acids are bound to coenzyme A, which creates fatty acetyl coenzyme A. In order for this to be created, an ATP molecule has to be used. Now, this is when the translocation phase happens, and it moves the fatty acetyl coenzyme A into the mitochondria of the cell. So that's the translocation. So it's moving it from skeletal muscle into the mitochondria of the cell, which is what's going to allow it to all be broken down further. And it allows it for different energy systems to break it down, specifically the Krebs cycle. This is where carnitine transferase comes into play, and moves the fatty acetyl coenzyme A into the mitochondria. The next step is oxidation, which breaks the fatty acetyl coenzyme A into smaller molecules, allowing the Krebs cycle to take over and break it down. Acetyl coenzyme A is a 2-carbon molecule. So the first part of oxidation breaks the 6-carbon molecule fatty acetyl coenzyme A into a 4-carbon molecule, and then a 2-carbon acetyl coenzyme A, and then it breaks it down again into 2 different separate coenzyme A's, acetyl coenzyme A's. Yeah, that's where the Krebs cycle takes over and uses the acetyl coenzyme A's to make ATP and go from there.